electromagnetism. The science of electricity and of magnetism developed separately till 1820. So before 1820, the development of electricity and magnetism were separate. These developments were separate. If we talk about electricity, so this science is 2600 years old, rather very old science. And the registered knowledge of the science of electricity comes from the Thales of Miletus, a person who knew something about electricity, or who actually discovered something about electricity. That was that when a rubbed piece of amber is brought near to bits of a straw, it attracts it. So rubbed piece of amber attracts bits of a straw. This was the first knowledge of electricity, or in the field of electricity, almost 2600 years ago. And the same way magnetism developed. The observation that magnetite is a stone, a naturally occurring stone. Magnetite attracts iron. This knowledge was the birth of the science of magnetism. And students, these two sciences developed separately. And in the year 1820, these two sciences merged. Or we can say a relation was developed by a physicist whose name was Hans Christian Ørsted. This person developed the relation between electricity and magnetism in the year 1820. And a new science has taken birth, the science of electromagnetism. Let's see what was the observation of this physicist that led to the birth of electromagnetism. What he observed is this: an electric current wire attracts or affects, I won't say attract, it affects a magnetic compass. Hence, the relationship between electricity and magnetism was developed, because the electric current wire affects a magnetic compass needle. And combining these two sciences, he started the science of electromagnetism. Student, further this science was developed by many physicists. Among them, Michael Faraday plays an important role. Then comes James Clerk Maxwell. His achievement was huge. He has given few fundamental laws of electromagnetism. These laws of electromagnetism is equally important in the field of electricity as the laws of motion is important in the field of mechanics given by Newton. We can compare his achievement to the achievement of Newton. In that way, you can see how important the laws given by him are. Maxwell's deduction is phenomenal when he said light is electromagnetic in nature, and we can find the speed of light by doing or by making purely electric and magnetic measurements. Now see, this man connected the three sciences: the science of electricity, the science of magnetism, and the science of light, that is optics. And thus, Maxwell's equations gave the way in developing the fundamental principles behind all the major electromagnetic and optical devices that we use on a daily basis, that are motors, cyclotrons, computers, radio, television, radar, microscopes, telescope. So the principles that runs behind all these devices, example, computer, television, microscope, telescopes, radio, are the equations of Maxwell. After this comes few more scientists in the field of electromagnetism who are behind the substantial development of this field, in which H.A. Lorentz, Heinrich Hertz, Marconi are very important. Students, this is the brief historical overview of electromagnetism. You can consult internet or any other book to know more about it. But this is what the basic of electromagnetism in terms of the history. And when we will start our chapters, then we will see the remarkable developments in the field, step by step. Thank you.